Alright everyone, welcome to day 19 of Advent to Code. A few seconds here, we'll get into it. Here's hoping it's not too bad, we can solve this without too much issue, but at any rate, let's do this. Day 19. The elves of Gear Island are thankful for your help and send you on your way. They even have a hang glider someone else stole from Desert Island. Since you're already going that direction, it'd help them a lot if you'd use it to get down and return it to them. As you reach the bottom of the relentless avalanche of machine parts, you discover that they are already forming a formidable heap. Don't worry though, a group of elves is already organizing the parts and they have a system. To start, each part is rated in each of 4 categories: extremely cool looking, musical, aerodynamic, and shiny. Then Xmas, okay. Then each part is sent through a series of workflows that will ultimately accept or reject the part. Each workflow has a name and contains a list of rules. Each rule specifies a condition and where to send the part if the condition is true. The first rule that matches the parts being considered is applied immediately, and the part moves on to the destination described by the rule. The last rule of each workflow has no condition and always applies if reached. Consider the workflow. Okay, this workflow is named EX and contains 4 rules. If workflow EX we're considering a specific part, it would perform the following steps in order. X is if the parts X is more than 10, send the part to workflow 1. Otherwise, if parts M is less than 20, send the rule to 2. Immediately reject and then accept. Okay. If a part is sent to another workflow, it immediately switches to the start of that workflow instead and never returns. If a part is accepted, the part immediately stops any further processing. The system works, but it's not keeping up with the torrent of metal, of weird metal shapes. The elves ask if you can help them sort a few parts and give. All right. The workflows are listed first, followed by a blank line. Okay. 3 parts are accepted. What do you get if you add together all of the rating numbers for all of the parts that ultimately get accepted? Okay. Which is X, right? Oh, wait. What? Oh, adding all those up. Okay. I think I understand what this is asking. So do that. So we're gonna have to go through, and parts is gonna be equal to input split. Interesting. Let me do that. Split on double new line because that's where we get the spacing. So first we need the workflows. And it's going to be parts 0 split on new line. Oh, new line. Need one of these. Okay. We're gonna map workflow. So we're gonna have the name is gonna be equal to substring from 0 to workflow index of the little first curly brace. Conditions gonna equal to workflow substring from this +1 to this, and then we're gonna go ahead and map split this on commas. I'm guessing it's gonna be all less than or equal to's. And then we can do is a map condition and so what is this called? This is category is going to be equal to C char. I can just do a substring. 0 to 1. And then const compare is going to equal to 1 to 2. And then the value, let's just call it, is going to be c dot substring from 2 to c dot index of the little colon there, and then it goes to the let's call it result or action. C substring from this on. Okay, so we have all these individual bits. So what we do need to do is we need to return, I guess technically actually return all of this. Actually no, some of this is going to be moved because we're actually going to need some of this. So we'll just do this way. Category, compare, value, action. So we're going to then call so this is a condition. So I guess we can call execute. Which is going to pass in v this is actually a parse int. So we're going to do is if compare equals this, if we need a return method on this. Actually, you know what? Maybe this won't go there. We'll just do this for right now. I'm gonna put this here. Okay, so now we have all the workflows. So now what we need is all of the parts. I called this parts, didn't I? Input sections, because this is parts. Input sections 1. Split this on a new line, and go ahead and do a map on this. This is going to do is it's going to return substring 1 to p dot length minus 2, so that way we don't get this. And then we can split this on commas, and then we can map this. And all it's going to be is return the category is going to be equal to I substring 0, 1, and value is going to be equal to parse int I substring 2 and on. Okay, so now we have our parts. Actually, this should be probably reduced, to be honest. So what I should actually do is part info, and then I should actually do this. That way I get the X, Y. Okay. So now we have our parts. So now what's going to do is parts for, I guess I can call reduce on this. Some parts start at 0. And what's going to happen, I guess we just start at the top. Oh, you start it in. Gotcha. Okay. So we can do is const workflow is going to be equal to workflows. I guess, yeah, this is a map, but this should actually be a reduce as well. Where it's going to be the exact same, except for that's not going to be the same, but that, and then we're going to return workflows, so it's going to be, whoops, name and conditions. So I need to type here real quick. Category is a string, compare is a string, value is a number, action is a string, and there. Cool. So there's our workflow. So it's going to be then workflows starts with in, results is going to have to be a let, and what we have to do is workflow or maybe we'd just do a do while. Const results while results does not equal a result. Sorry, it's a and. Right, it should be the same. Oh, result is going to equal to workflow so you're going to pass it into the first. Workflow conditions 0. The workflow is going to be equal to that for now. I don't know how to do multiple, but we'll do what to do is if compare, if the workflow.compare is that, maybe this should be for let I equal 0 while I is less than workflow.length I plus plus. Maybe this should be like that. And we get I, and so we can then just do a compare. So it's gonna be if, else, I don't know what else would be. So we can then just do a check is if parts because it's going to be part category is greater than value. That means it's true, which means results is going to be equal to action. Otherwise, we don't do anything. Otherwise, we just continue. Whereas this one is the opposite. Otherwise, we continue. So if it's true, we get a new result. Actually, should we be doing this? Oh, because I need to know if it's A or R. Oh, but there's sometimes it's just an A or an R. Okay, this parse won't work. Split map. We do need to check is if I can just do this. If C equals, or I can do this. If category equals A or category equals R, that means that we're just done. So we can just return category of, doesn't matter. Yeah, it doesn't matter. Compare is going to be equal to, we'll just do equals to make life easier. value doesn't matter. Action is category. Okay. What was this? Okay. So now what we have to do is a quick check. Compare is our equals sign. That means we're done. So that means we can do is results equals action, right? We still said action. Yeah. Make life easier. Workflow. Right. So now we do a check is if workflow dot action. Oh my gosh, I may just do this. Const is accept reject. I'm had enough. I'm gonna have to keep doing this, so I might as well. V category, and so now we just do is accept reject, and we pass in action. If it is, do that. Otherwise, otherwise we need to set the workflow to this and break out of this for loop so we can begin the next one and do this here too. All right, what's our issue? Reduce, right? We're not doing returning anything. Return some. So what happens then is we finally get a result, and we can just do a check is if I can do sum plus results accept, reject is 0, accept is going to be object dot keys of part reduce sum to key sum to plus part K. Alrighty, that should handle this all. And now we have part 1. And so I can do a console log part 1 and send part 1. Okay. Alright. What am I even gonna get? Probably something not legible. Maybe nothing, because it's not gonna end. Okay. Oh, because it's RFG. Gotcha. Actually, it's gonna be C, isn't it? Okay. And we're gonna do the exact same thing here. Is that okay? All right, that should help. Yeah, it's RFG. No. Oh. Gotcha. That's because that's how I checked it. Does the last one never have a condition? Oh, the last one never has a condition. So actually, see, we can just do is if I equals array length minus 1. All right, try that now. Beautiful. There we go. There we go. Oh, I got an answer. 4, 5. Nope. Nope. Okay, so those all work. At least I'm getting some sort of answer now. Oh, I'm cutting off too many. It gets cut off. 1. There we go. Okay. All right. Which means all my console logs go away. So then, now it goes away, and now I can just go back to my input. And I get that, and not right. It's because I'm not breaking. Oh, that's still a different answer. Maybe it's because I wasn't breaking correctly. There we go. All right, even with help, the strongest, or even with your help, the sorting process still isn't fast enough. One of the analysts comes up with a new plan. Rather than sort parts individually through all the workflows, maybe you can figure out in advance which combinations of ratings will be accepted or rejected. Each of the 4 ratings can have integer values ranging from minimum of 1 to maximum of 4,000. Possible distinct combinations of ratings. Your job is to figure out which ones will be accepted. In the example above, there are distinct combinations of ratings that will be accepted. Consider only your list of workflows. How many distinct combinations? Is this another range splitting thing that we did a while back? It's gonna be another like range splitting. Okay. Okay, it's gonna have to be its own. Okay. There's no parts. So there are ranges now. So that kind of goes away. So what happens, so it's now... This needs some nesting, actually. This is gonna need nesting. So we're gonna need is where's the part? Const it's xmas, so x is x min is 0, x max m a s s. So here's our part. So starting at this workflow, forget result. We do need this to be sum though. If we get to an add except, we do need const calc part sum. These are all gonna be numbers. Part. So it's taking part. So what's gonna happen is it's gonna do this. Part 2, part, we're just gonna do this. Pass it that. So what's gonna happen is sum, this needs to return sum. So gonna happen. So we have this value, right? So this is greater than is true. So that means we have to split this part to where half of it continues, half of it goes down a recursive call. So const part split. Now to figure out how we split this. Does not equal x. That makes life easier because then we can just do part x min. X M M A S S S S A M M. Okay, so with part split, this is the true bits. Is this do even necessary? Real quick. We get our answer, right? Get rid of that. Is this do anything? I'm just trying to. It probably does. Yeah, okay. Oh, because it gets to the next workflow, right? Okay. Which means we probably don't need it here because it's each workflow is here. Because if we get to a new workflow, well, no, not necessarily. Okay. Okay, so this is add accept rejection, which means because part will be true, part will be false. I don't know why I moved this to here. So the split, so with the greater than, the split becomes everything greater. I need the max. Because this is everything that's true. Oh, it doesn't matter. It could be false though. No, because it's false keeps going. So everything that's true. So everything that is greater than this. So we need max of part dot xmin and value. And same with this. Except this is x max. So that means these all become this, just with their own respective value. Oh, except I didn't do these across. Yeah, I didn't do these across. I didn't do these across. Okay, so there's the part. So this is the part that is true. So if it's an accept reject, that means we're done. So this actually needs workflow. This actually needs this. So that means it's done, so we can just do is sum plus equals all distinct combinations of ratings. So if we have 3, 3, and 3, how do you do? It's a choose, right? Is that really the formula? It's just multiplying across. No. I'm thinking I'm getting too deep in this. It should be just all across. So it should just be part split dot x max. As if we get a 0 on any of them, okay. Minus x min okay, times m min m max a min s and s. Okay, so there's one down. If we get to this one, this actually brings us into this. So we get sum plus equals. Let me do it actually this way. Sum plus equals this, pass in part split. So this is where the do shouldn't be necessary because we don't handle that here. Okay. What? Oh, I did it backwards. Okay, so there's that. So now we get to the next part split. But these are all just gonna be mins now. So we want everything below this. But we can't. Whoa. Well, we can't exceed this. Hold on, no, these aren't right though. But math dot min of this and part dot x max. And then this is min. So these are all mins. It's just that these are slightly different. Oops. Mmax, Amax, Smax. I think that's right. Okay, so that means this gets brought down to here. The only difference is that now this is the max. Is it the max? X-min, so we're going less than So this just becomes the max. And then this becomes the min. This flips around, right? So this is the max of x min in value. No. Hold on. This is everything that's true. X max is the min value maxed. The smallest of these max with x min, whereas the minimum value is going to be the max of x min. Okay, that's what I want. So I guess let me do this, this, and this, and then update these. Mn. Oh, that should be X max, my bad. A max, S max. All right, in theory, if I did that right, and this should all be the same regardless. Oh no, I do need that do while. No, I don't. Because what's happened to the other part? Part just continues on. Yeah, no, I do need the do while. Yeah, I will. So I guess, yeah, I can keep just changing workflow. Yeah, that should work. Because then it's gonna keep going through here. Okay. But what's gonna happen is it's gonna go through all of the workflows. Yeah, it's only if we get to the last one that continues on. Which in that case, no, we don't need the do while. We don't need the do while. We do need to do parts because it's when we get to here, this is where there's no branch. This is where we handle that. Okay. So parts. Part dot X max, or let's do X min. So X min. Well, this is just gonna be this, isn't it? Isn't this what parts becomes? But it's gonna be some -1 stuff. But I should be able to do parts equals this. Because this is gonna be greater than, so -1. Because that means, because it's the max of this can be 1 less, yeah. I guess I should do it this way. If I think about this right, that should be it. And we should get part to be here with doing a +1 on value now for this time around. Okay, and then we get to here. This is our final one. There's no last bit. So sum. Is there any need for result? I don't think results needed because results only being set equal. There's no do while. This is just gonna be part. Otherwise, if it's not, we continue on with this workflow. We do sum like so, but we give it part instead of parts. That. Good? Maybe. Let's just see what happens. What's the worst that could happen? We get 0. That's what's gonna happen. Okay, I'm gonna do is do a const calc sum. I'm seeing this all over the place and it's really annoying me. Also, that way I can do a check in here, return. Maybe I can do a console log, make my life a little bit, not easier, but help myself a bit. Okay. X-min doesn't change. Why would X-min change? This is everything that's true. X-min should never change. Why would it? Under no circumstance does this change. Okay. So then for true, in no world does the max change. Okay, I made this way more complex than it needed to be. Okay, and so then this is the opposite. Okay, so then what's okay, we're making progress. We're getting close. We're getting there. Not quite there yet. This is what I got, and this is the answer. All right, we're getting there. We're getting there. So I'm missing something with the other split. So this is the false bit. So this is everything there. Obviously part. And so can the min can't be affected by this. I just realized that these are all these are both the same. So the max unaffected, so that means the min should be unaffected. The part, this should be the min. Min shouldn't be changing. Which means that max isn't changing here. Good, that didn't change my number at all. Okay. Oh, I'm not checking accept. That would probably be a good idea to only do the accepts. That looks a lot. Oh my, it's so much closer. Oh. I'm so freaking close. Alright, it took me a lot of work. Realistically, I was there. It was just a lot of. It turned out that these +1, -1s were all wonky. I guess they all go up here. And then I realized I misread the question to be, it starts at 1. And then also adding this. There was some help from Reddit, some help from here. I was there, just some small math wasn't right. So, at any rate, though, there we go. There's the code. That gets me my answer. Yeah. So, explain this. So part one's pretty straightforward. This is my testing. We just go through our inputs, we parse out the instructions, so this is being the name, the cases, and the results, parse them out, and then for part one, we just go through each of the parts, grab the workflow that starts it, which is the in, then we have this do while, this controls what workflow we're currently in, and then given the current workflow, go through all of the different conditions that are in the workflow, which is right here. The condition actually be condition, not workflow, but sure, condition. This is the comparison it's making, and then depending on the comparison it's making, you will decide if it's true. There's the whole except range, which is the A or R. It's one of those. We have results. We can break out of this for loop, which actually can end up this do while. I think this do while and for loop can be condensed, because there's a lot of breaks. Yeah, there could be some condensing. I'm not sure. This is just kind of a lot of random logic. But it's just following the steps that it's kind of giving you to do it. I guess this is a bit hard for me to explain. And then we just sum up all the answers. Part two is the same, but what you're doing for part two is you're just treating, instead of multiple parts, you're just treating it as one big part that has a range. So if you remember, I don't remember what day it was. It's like day 8. It was one of the earlier days where we had some ranges. Here we go. It's day 5. Same concept as day 5, where you have your ranges. And basically, given the conditions that we had part 1, what we do is we just take those ranges, we split them up into 2, with one range being the true range, the range that is true for the comparison, and the other range being the one that's false. For the one that's true, we then throw that through a recursive call if the true nature returns a new returns a new workflow. If it returns a new workflow or a label for a new workflow, we just call this recursively to get the sum for that. If it returns, if that condition for true is actually an A or an R, we just calculate the sum for this and add to our rolling sum. Yeah. Yeah, this is a hard one to comprehend, to explain how it works, but there we go. We got there in the end. Yeah, hopefully you guys enjoyed. Day 19 is done. Thanks for watching. See you guys all tomorrow for day 20. Peace.